Hello everyone, welcome to my channel. Here I'll be sharing with you all O-Level Mathematics 7th edition, that is the D series D1, D2, D3, D4 chapter wise notes and solution of the exercises given at the end of each chapter. So anyone of you who's willing to practice mathematics with me and who wants specific notes and formula sheets and everything related to each and every topic can subscribe my channel and hit the bell icon so that every time I upload a new video related to O-level mathematics, whether it be the notes or the solution of the exercises, so you'll be notified immediately and you can watch it to solve your queries and doubts related to it. So today we will start with the notes for the first chapter of the book D1. It is very important to go through all these notes and make sure that you're confident with it before you move on to solve the exercise 1A. So first of all, I hope every one of you know what is a prime number. Prime number is any whole number that has two different factors. The factors will be 1 and the number itself. For example, 2 is a prime number. Why? Because it has only two factors, 1 and the number itself, that is 2. 3 is also a prime number because it has only two factors, 1 and the number itself, that is 3. So any number that has only two factors, and what will be the two factors? 1 and the number itself, will be called a prime number. For example, 7, 11, 13, 17, 19, 23. All these numbers have only two factors, 1 and the number itself. So they are called prime numbers. So next is composite number. So I'm sure most of you will know what is a composite number. Any number that has more than two factors will be called a composite number. For example, let's take the number 4. 4 has many factors like 1, 2 and the number itself, that is 4. Since it has three factors, it will be called a composite number. Similarly, 8. 8 has more than two factors like 1, 2, 4 and 8 itself. So it has four factors. So it will be called a composite number. Similarly, I've showed you many examples like 25. 25 has 1, 5 and 25, three factors. So it is a composite number. Similarly, 16. 16 also has many factors like 1, 2, 4, 8 and 16, the number itself. So it is also a composite number. So any number that has more than two factors will be called a composite number. Okay. The next thing is, if you get a question like state a number that is neither prime nor composite. So most of the students will get confused that which number is neither prime nor composite. So let me tell you, the two numbers 0 and 1. They are neither prime nor composite. As you can see on my screen, I have mentioned on the notes also that 0 and 1 are neither prime nor composite. Okay, let's come to the next question. So the next thing is that you get questions like identify whether the given number is a prime number or a composite number. So how do you do that? It's simple. You need to find out the factors of the given number. If it has only two factors, that is 1 and the number itself, then it is a prime number. And if it has more than two factors, then the number is a composite number. Like I have already showed it to you in the previous examples. You can see it on the notes also, and I've explained it to you also. Okay, so next we learn about the index notation. Square of a number. Now what is square of a number? If a number is multiplied twice, that means 2 times. So we can write it as 5 squared or 5 to the power 2. As you can see on my screen, the 5 digit is written in the normal size and 2 is written in a very small size on the top right corner of the number. So that is called 5 square or 5 to the power 2. So similarly, any number, if it is multiplied twice, that means 2 times, so you do not repeat it 2 into 2, 3 multiply 3, 4 multiply 4, 5 multiply 5. No, you can simply write 2 square, 3 square, 4 square, 5 square and so on. Next we have cube of a number. It's similar to square, just that here the number will be multiplied thrice. That means 3 times. So if any number is multiplied 3 times, 5 into 5 into 5, so you need not write it 3 times. You can simply write 5 cube or 5 to the power 3. So how is it written? 5 is written in the normal size, and then 3 is written on the top right corner in a very small size. That is called 5 cube or 5 to the power 3. So similarly, if you multiply any number 3 times, 10 into 10 into 10, so you can write 10 cube, 11 into 11 into 11, so you can write 11 cube or 11 to the power 3. Okay. So similarly, if any number is multiplied many times, maybe a number is multiplied 4 times, so you can write 5. If 5 is multiplied 4 times, you can write 5 to the power 4. If 6 is multiplied 6 times, so you did not write 6 multiply 6 multiply 6 multiply 6 multiply 6 every time. It will become very lengthy and boring, obviously. So we write 6 to the power 6. If 10 is multiplied 4 times, so we write 10 to the power 4. So the index notation gives us an easier method of writing a lengthy process and also a convenient form, because no one likes to write 6 6 6 6. It becomes boring, right? So that is the you can say benefit of writing in the index notation. It saves your time and space and looks more readable. Okay, so the next thing is to find out the prime factors. So if you can see on my screen, I've already shown in my notes. Prime factors are those factors which are prime in number. Any composite number can have a lot of factors, but all factors are not prime. For example, look here, I've done for 18. 18 has 1, 2, 3, 6, 9 and 18 as factors. But out of all of these, only 2 and 3 are prime in nature. So 2 and 3 are the prime factors of 18. Similarly, for 25, you can see 25 has 1, 5 and 25 as its factors. But only 5 is prime in nature, so 5 will be the prime factor for 25. Similarly, if you see the last one, 42. Now 42 has many factors and I have written them 1, 2, 3, 6, 7, 14, 21 and 42. But out of them only 2, 3 and 7 are prime numbers. So they are called the prime factors for 42. Okay, so the next thing is to find out the square root. Square root is just the opposite of square. Like for example, like I've showed you, square root of 4 is 2. So square root of any number, any value will be the number which can be multiplied by itself to get back the value. For example, I have shown you square root of 9 is 3. So if you multiply 3 into 3, you get 9 back. So square root will be the number which will be multiplied with itself to get the value back. For example, square root of 16 is 4. So 4 into 4 is 16. That means our answer is right. If you multiply that number again with itself, you get the value back. Square root of 25 is 5. Square root of 36 is 6. Square root of 49 is 7. Square root of 64 is 8, and so on. So square root of any value will be the number which can be multiplied with itself to get back the value given to us. Similarly, the next thing will be cube root. Cube root is the opposite of finding the cube of a value. It does the opposite. So cube root of any value will be the number which can be multiplied thrice. That means 3 times with itself to get the value back. For example, cube root of 27 will be 3. 3 into 3 into 3 is 27. So cube root of 27 will be 3. So any number that can be multiplied thrice to get the value back will be the cube root of that value. For example, cube root of 64 is 4. That means 4 is multiplied 3 times to get 64. Similarly, cube root of 125 is 5. 5 multiplied by 5 is 125. So cube root of any value will be the number which can be multiplied 3 times to get the value back. So a perfect square or a perfect cube will be any value from which we can calculate the square root or cube root. For example, 4 is a perfect square because the square root of 4 is 2. 16 is a perfect square because the square root of 16 is 4. 25 is a perfect square because the square root of 25 is 5. Similarly, 8 is a perfect cube because the cube root of 8 is 2. 125 is a perfect cube because the cube root of 125 is 5. So I've given you all examples. So they are called perfect squares or perfect cubes. Now, what do you do when you have any value that is not a perfect square or a perfect cube? So for those values, we need to calculate the estimate, and I will show you how to calculate the estimate while solving the exercise 1A in my next video. So make sure you subscribe my channel and hit the bell icon so that when I upload the next video, you are updated automatically. The next thing I have shown an example is square root of 50. Now 50 is not a perfect square. You cannot multiply any number twice to get 50. So what we will do is we will try to find out the nearest perfect square to 50. So 49 comes before 50. It's just before 50, so it's the nearest value. So 7 times 7 is 49. That means the square root of 49 is 7. So this is a perfect square near 50. So our estimated value for square root of 50 will be 7. This is not the perfect answer. This is just an estimate. And if you are not allowed a calculator during your exam, you can give an estimated answer for any value that is not a perfect square or cube. So that's it for today. These notes or terms are enough for you for the exercise 1A. So I will upload the solution of the first exercise, that is exercise 1A of the book D1, 7th edition of O-level mathematics, very soon, maybe by tomorrow. So make sure you go through all these notes very properly and carefully so that you can understand the solution of the exercises clearly. Till then, remember me in your prayers, and if you have any other question, you can ask me or comment in the comment section.